My name is Juan Francisco Ropero Pinto. I'm working for Synaptics. I'm happy to present you today our overview of the AI on the edge. I have been working with processors since more than 10 years now, and everyone is talking about AI in, I don't know, with ChatGPT and all these things since 1 year. But we have been working on this for a long time, and we have the proof if we have integrated in our processors already MPUs. So we have them in hardware since 2019, 2020. And yeah, people are discovering this. It's nice that we are there to address the use case that the people need. Okay. So edge AI is here to stay, edge inferencing. Why I put that? Because we don't want to send all our data to the cloud. It's not GDPR compliant. It's, everyone have trust issues. If you send all your face recognition data to the cloud, nobody likes that. In Austria, you cannot do it. In Germany, you cannot do it. So of course, this is evolving. So our processor allows you to do that in the MPU. Stay safe, it's secure, signed, encrypted. Other point I put is response time. Of course, if you don't need to go to the cloud, how much faster it is to give an answer. So yeah, when you need to recognize someone, or if you need to ask to the cloud a question, it takes time. If there is no good connectivity, all we know that this is time. Everyone knows that if your Wi-Fi is far from your router, it's not working well. So we have a lot of tools to make accessible a lot of answers from the SoC. And then, of course, if you have an answer you cannot give in that moment, then you can do a fallback on the cloud. But in general, most of our products have far-field voice on the edge, which is big advance in the last years, as I say. So we can do natural language understanding. We have NLUs. You can dictate something to our device. It will write it down in a text. You don't go to the cloud for that. So that's something we are progressing, and we are getting better and better. Yeah, what I said before is available. You don't need to be connected to the internet. If you go to our booth and you play our games, nothing is connected to the internet. Everything is happening there, so you can do all the processing on the edge, not being connected to the Wi-Fi. That gives you a lot of freedom. And yeah, things are evolving on that sense. Of course, with Google, Amazon, probably they want to have some part of this big cake, no? And we are trying to use it when it's necessary, the cloud, but when it's not necessary, you should do the processing on the edge. I didn't put it here at something interesting about edge AI, and I think in the next years also it is a selling point for us, and it will be a selling point for everyone. It's much more power efficient. If you need to go to the cloud to do face recognition, that takes much more power. If you count all the transfer data to the cloud, to the server, come back. If you do it in your processor, in your MPU, it's much more power efficient for sure. So I'm transitioning a little bit now. I'm just presenting edge AI, which everyone knows, no, and the advantage. Disadvantage, I wouldn't say there is no many disadvantage of edge AI. The only thing I see is that sometimes you need internet for answering some questions, but the rest, you should be able to do it on the edge with more and more computing power we have with less consumption. These are products that I'm working on, and some of them are already deployed, some of them are in development. These use cases are super interesting. For example, I work with companies doing video conference devices. So when you go to a Microsoft room, Microsoft Teams certified room, you have the camera pointing to you, like cutting your head and put it in a square somewhere. We can do that on the edge. You don't need to go to the server of Microsoft to do that. So we have a lot of models that can do that. This is the auto framing. We are testing that with several companies doing video conferencing, but of course there are always Zoom, Microsoft, they want you to do that in the cloud. My opinion, you should do that on the edge, it's faster, and if the connection is not good, you can do that anyway. Biometrics, we have our processors are being more and more deployed in places like train station, airports, police stations. We can identify people, we can predict where the people is going. We have products now in the market. It's not for the public, but that you can track where the person is, how much time is standing somewhere. You can predict strange behavior. All of this being in the edge and not sending the data anywhere, it's good because again it's GDPR compliant. Sports and gaming on the edge. So you have seen that demo in our booth. I don't know if you didn't have the time to go there, please go there. We have this funny competition between two players where they can clean a window. So the camera will detect your body posture, it will detect your hands, and then it puts some mud on the window, and then you go and clean it. No, it looks stupid. It's quite funny. So please, if you want to play, go there. We are actually deploying this kind of products with some operators, with Deutsche Telekom in Germany or in the US. Co-watching is a big thing. Most of you maybe you live here in England. Sky is doing this, no? That there is a Manchester United against Liverpool, so you can watch that game with your friends. So if you have one of our cameras, you crop the people watching the match. You can put them in a square. You can interact with your friends. Of course, now Corona is not the pandemic. Thankfully, has finished, but that use case is still something that people want more and more. We have deployed it in Germany with Deutsche Telekom. We are deploying it in many other countries. This is nice feature you can do on the edge. A lot of AI. So there is a super cool product we have deployed in Taiwan. This is something super cool you can use for your companies. I don't know what you do exactly, but everyone that, if you are here, you do some IoT. So this product we are doing in Taiwan counts the people in the bus stop. It's a digital signage. So we have the control of the panel that is in the bus stop. So it will detect who is waiting for the bus. So if it's a female of 25 years old, so it will target ads for this person. We will detect the age, the gender, and we will put some advertisement of cosmetics, for example. And then the bus driver will know how many people are waiting in that bus stop, so it can handle the space on the bus. Yeah. This is a real product, and this is already in the market. So as you see, this is like exploding. All of this is edge AI. Nothing, for example, this digital signage everything is happening in the cloud, in the device. You are not allowed to send anything to the cloud. You cannot send the people's face, right? Okay, so I go forward. That brings me to a little bit of the architecture of our processors. what we do finally. So this is some of our products. That's the Google Nest. I've worked on that. It has the ES370. The far-field voice, Google send it everything to the cloud, but you could do it also on the edge. This is the architecture of our products. Usually we give you all the edge AI tools to import your models, to optimize your TensorFlow models or Caffe models, whatever you have developed. You can use our toolkit. It will optimize that, and it will make it perfect to run in our NPU. So usually we give that tools. We give Yocto, Android, whatever Linux version you need, RDK. That's based on Yocto too. That's the software environment. That's open source usually, and then we give this is what we sell, the processor. We have different processor, very powerful processor. We have processors that goes to 4K DMIPS. So you can imagine with that computation power, 40K DMIPS plus 7 teraops, you can really do a lot of things. Like I said before, you can estimate the body posture, depth detection, how many people are behind you. We have other processor where we have an M33, small ARM device. So that's only for battery power device. We can do some kind of person recognition with this processor. We have some programs that can detect if someone is falling in a battery power device. This is another kind of AI on the edge that we can do. We cannot do we cannot go to complicated models like with the big processors, but we can do a lot of nice, simple stuff that you want to control. For example, in the elderly houses, people are good. We have a product that can detect if the person went to the toilet or not during the day. Okay, so I'm talking about the tools. This is something related to Synaptics, but I guess if you are interested of having a solution that you can use from top to down, this is kind of things you can generalize that for any AI product that is well developed. What I want to emphasize is like for edge AI is super important that you can do encryption and sign your models. This means it's very important that nobody can hack your device, your Linux, and then take the models or take the data that you collected from the people, like the face. So our processors are coming from video processing mostly, so we have a nice environment that is encrypted. So everything around the video pipeline in our processor, it's completely secure and encrypted. So if you want to run a model on the video, you will need to sign it and encrypt it. We give the tools for that. And that, as I say, that allows that nobody can hack your device, so you are sure that's running safe and nobody can extract data that you are interested in. That's, I would generalize that could be a condition for everyone that has a processor. Unfortunately, not all processors can do that, or not the other companies, they don't invest that at all. They don't invest on that because it's expensive, right, to put this environment where you need to encrypt everything. Okay, so I'm pitching a little bit our processor because I want to explain. This is what you need to do. This is what we have figured out that we need to do for AI on 4K videos. So our processor is called 680. We have a quad-core A73. We need this kind of big processor to allow to process 4K videos or 30 FPS or 60 FPS. If you don't have that kind of processor, you cannot access every frame. We have a big GPU because we are interested also to have nice videos if we have a big screen. Then the NPU that I'm talking about, this is a huge NPU. 7 teraops means that you can process big models on, as I say, on 4K videos in every frame. So this processor is going, as I said before, to smart monitors, digital signage. Originally, Synaptics was selling this processor in set-top box. We are still selling it. We have worked a lot with Sky. We still have some products with them. And the path that we went is from the set-top box for more industrial application where you need AI on the edge. Still, AI is used in operators too. For example, they are very interested to know if you are watching a movie and there is a lot of Nike T-shirts, so you can just do your model that is looking for this brand in every frame, and then you can target the ads of whatever is playing in the video. We have a demo about that too. You can come to our booth. As I say, we have this processor is working in video conferencing, smart cameras, people flow, counting people, smart signage, bus stops. Okay. So this is how a NPU should look like. It's our NPU, but if you want to do like, if you want to be efficient, we figure out more or less this is the architecture that is best. So we have a bus here, the Axie Fabric bus. It can be accessed by the NPU the same way you can access it by the CPU, the GPU, the encoders of the processor. We have some also video encoder. So that makes the NPU very efficient. It can access the RAM memory there on the corner. It's important to see that in our NPU we have an SRAM too. This is more memory. It's very important to make faster the convolutional core operation. So all the temporary data is not needed to be stored in the RAM. We store in the SRAM. Small memory, very fast, and then like this we manage to have an inference time very low. So we can compute the models very fast. We are if you would ask me which are the best quantized model, I think almost everyone is doing int8. So we are adapting our drivers for that. So the best is TensorFlow Lite 8 bits. We support OpenCL, OpenVX. Of course, you can also execute floating point 32 bits, but then it will take much more time. Doesn't make much sense. So it's nice to see the architecture. I like to show this slides so you can see how a processor works from the inside and how we figure out the NPU was more efficient. So from the other slide, I'm coming here now because how you measure an NPU, no? So of course we need to market our NPU to the to our clients. And we need to see how we measure against others and how to make it more efficient. So we have been working a lot with this company. It's called AI Benchmark. You can go to that website. You will find all our competitors, Qualcomm, NXP. I didn't want to put them on the slide, but they are below. So you can go to ranking IoT. It's written here. And then you can check if you are interested of this kind of inference processors, A73, A55. Please check it. I wanted to show that it's not only the hardware that you sell. You need to have good drivers. So when we did the tape out of the chip, we did it in 2 years ago, 3 years ago now. You can see the AS score was not so good. No, the inference time, the initialization time of the models, accuracy. So we have been working a lot in drivers of the NPU plus the toolkits. You know how to optimize the toolkit that generates the models that goes on the NPU. It's a huge difference. So please go to that website if you are interested. They have a lot of insight also how to test different NPUs in different phones, devices, the models that you should be using, and what you should take into account to make this kind of scores. But at the end, what's most important is the tops. If you go to buy a processor, you see all the marketing people, they say, I have 6 teraops, I have 4 teraops. That doesn't mean much at the end, because there is not a single model that use the whole computer, the whole processing of that NPU. There is no model that if you advertise, I have 4 tops, if you use mobile nets for wherever, it will not use this 4 teraops. So at the end, it's the processing time, the inferencing time, that it counts on how good is an NPU or not. So this is what we are measuring, and we compare ourselves with other chipsets and also with other parts of our processor. So we compare the NPU against the CPU. Of course, in any model that has a lot of convolutions, in the NPU is so much faster than in the CPU. So that's milliseconds. So Inception, for example, is an open source model. It takes half a second in the CPU to execute it in the CPU. It takes 20 milliseconds in the NPU. And then like this, you can leave the CPU for doing whatever else task the processor needs to do. So we try to teach our customers how to use the processors too. As I say, I write it down. At the end, what's important if you are working with different processors is to measure the inference time. This is the way you will measure how good it is or not. And of course, the power, because it's not the same taking an NVIDIA processor that is consuming like 10 watts to another processor that is consuming 2 watts, right? So, okay, what's the time? So from there, okay, I talk about the NPU, the processors, the NPU. So now let's talk a little bit more in depth about some real AI models that are deployed on the market. We have deployed them in our processor. We did that models. It's working pretty well. So what I'm showing here is a super resolution model. This means when you get a stream from the internet, it can be in SD quality, it can be HD quality, it can be 4K. If there is not good connection, probably you get it in HD, 720 pixels. And then nowadays, all TVs are 4K. So what happened there? At the beginning, all the scale of that was linear. We were just using hardware scalers from the TV. So we are just putting, if you had 2 points, you put a point in the middle, and you try to interpolate them. So the quality of the image at the end, if you do it like this with linear interpolation, is not very nice. I mean, you can see you could see in the TV that the resolution of the video was not good, right? So we have improved that using AI models. You can really see a big difference. Maybe not here with the with the projector, but these are some images that we were trying. So this, you can see this. We received the video. This is 720 pixels, and then we scale it to 4K. The hardware scaler is really not working well, and if you would work in video processing, you look right away where you find some shapes. You can see they are much more sharper using MPU. This is a big difference. So this metric is coming from Netflix. Netflix is, we use it in all our products that goes into TVs. So it's important for us. And you can see the hardware scaler is not working well compared to the neural network scaler, to the super resolution model. So actually, it's the MPU is bringing something that the operators in this space they really appreciate, that the upscaling is so much better. Okay, so I just put the same picture. That's the MPU one. That's the hardware linear scaling. So super resolution is beating the other one. Okay, so I wanted to show a real use case of where Edge MPU is bringing something that didn't exist before. Now, I just wanted to present a bit our tools. This is, if you buy our processors, we try really to have an ecosystem that is nice for you, that is easy for you to start with and develop your stuff. So it's Python-based, Docker. So with simple command line, you can take your models and convert them in TensorFlow Lite if you want, or TensorFlow Lite 8 bits, and just make them run in our MPU. We spend a lot of time on model optimization. This, I think, more and more companies will start doing it. This is something that we have been doing now for 3 years, as I said, so we are getting much farther than others. I think it's a big differentiation. Some people understand that, understand now that Edge AI is really here to stay, so they are investing there. Okay, if you have after any question, you can ask me. I'm not going to read the slides. This is our driver architecture. I put this one more or less at the end because I wanted to show and I wanted to remember you that we really know how to do encryption on the models and signing them, so everything is very secure. We have an IP for that. It's called Secure. So all models, if you work with our processors, if you take our toolkit, you can encrypt them, you can sign them, and then you can run them in the trust environment of the processor, which means nobody can hack that, or it's really difficult. It has been validated by many companies that do certification for this. We also spend a lot of time on that. So you have just the normal user space. We made the libraries adapted to it. We have the kernel driver of the MPU that knows how to handle the encrypted models, and then it is passed to the TV. I'm good on time. Oh, okay. Because I have one last slide.
You can go with your last slide.
Okay, so yeah, I did this yesterday night because I thought I should not stop with that. So yeah, AI is getting a lot of attention now. The last month, everyone is talking about ChatGPT. Everyone is scared of the AI. They think probably that Skynet and Terminator are coming back. I don't think so. Who knows? People are scared of losing their jobs. I think we should use AI to improve our jobs. We have now we have a lot of experience on it, and it's getting better and better. We see a lot of traction. So actually, AI, from my point of view, it's going to help the people more and more. It's going to make life easier for everyone. As I said, we put NPUs since 2009 in our processors, and now everyone wants the same, so it's fine. And we are a little bit in advance, so it gives us a little bit of time to see how we continue evolving our processors. And yeah, if you don't agree, I just put that you can go and look for in ChatGPT how is Synaptics in this market. Thank you.
So in the beginning of your presentation, you mentioned that the machines that you had outside, the little games, all of those are actually not using any internet.
Yeah.
Now, in a world where internet is in every home, in everywhere,
Yeah.
why did you, it's not like, I'm questioning the company or anything, but what was the necessity for it to not use internet? Do you anticipate a world where the internet will shut down, or I don't know?
No, what?
Like,
You
what
know,
was the basic decision based off of? I mean, even for future technologies, if your aim is to not use internet's such a great thing. I'm sure everyone agrees.
Yeah, for sure. So we sell processors, so we want the people to use the processor as much as they can. And we think using the servers for AI is an error, not for everything, but for basic functions, like this gaming that you have seen in our booth. So yeah, you say everyone has internet, but what happens if the bandwidth is not good, no? For example, I can give you an example. I work with Swisscom, no? Swisscom has our processors, and in the World Cup they have 4K. In the first year of 4K, they were streaming all the World Cup matches in 4K. I can tell you their servers were a mess. There was no bandwidth for any other stuff. And they have like fiber optic to home there everywhere. So it is important that they can still work with lower resolution or without using much the internet.
So this is like a backup for internet.
It's a backup for
ultimately.
As I say, internet. It can be a fallback, or you can use internet, and then if something is not working, then you can use just whatever you find in the processor. Yeah.
All right, that's cool. Thank you.
Okay.
Thank you. So just with regards to how it absorbs extra information, for example. So if you're not using the internet, so let's just say it required extra information to do something, which already wasn't within its local resources, how would it download, would you say, the extra information?
So, for example, the NLU, do you know what is it? An NLU, natural language understanding. So you have a dictionary in your processor, and then you will have the NPU is big enough to be able to understand your voice and try to dictate what you are saying. You don't need to fall back to the internet for that.
Okay.
But of course, if what we do with some products, we try to do it inside the processor, and then if you cannot do it, then you fall back to the internet, and then you look for it in another ASR.
Okay.
On the internet, yeah.
All right, thank you.
Bit of a non-technical question, but if you could do anything with AI, what would you do?
Ooh. I maybe would create the perfect girlfriend. I'm single, so or probably I would create my Tinder profile with it.
Okay, thank you. Oh, you have one more? Of course, we have time.
How do you guys address the more of the natural language processing related problems other than like not the like image processing, but
Natural language. In fact, we have, this is called VS680. We have AS, which means Audio Smart 410, for example. And this is the, do you know the Google Nest product? This is running there. So it's an quad-core A55. So there you have enough power to understand the language of the people, you know. There are companies like, I don't know if you know Nuance. They have really good support of many languages. They have very, very good models for your voice. So it's quite good, you know. You, on the open source models on the internet, you can find they work also good, and you can import it to our MPU. And we have processors perfectly adapted for that. That doesn't have, they don't have GPU, but they still have MPU to run your NLU there.
do normally people in production like deploy the, I don't know, if they deploy large language models, like more like BERT, not the generative ones. Do they deploy inside these ones, or they just do some part of it?
So there is a product. It's a coffee machine, and they have natural language understanding. So you can say, give me an espresso, please, or you can say, I want an espresso, and the coffee machine will understand these two sentences. You don't need to, because if you remember the beginning of ASR, of speech recognition, was you need to say exactly what the machine wants you to say, and that was a catastrophe, you know. So now I think with this natural language understanding, the machines are getting smarter, no? So you can really say whatever, like I want an espresso, in the way you want to say it, it will understand. And we have products that are like this. I'm working also in a washing machine that can understand.
Can I ask what is the like memory of these products, and can we add extra like memory to them? It should be, but
the RAM memory, it's for this one you can have 2 GB or 4 GB. The audio with 1 GB, it's fine. You don't need more RAM. I'm talking about $6 chips, SoCs. Yeah.
Well, thank you for the answers.
Thank you very much. Please come to our booth if you want more information, or you want my business card, or you want to know anything about Synaptics. Just pass in our booth. Yeah. Thank you everyone.